So, welcome to lesson number 5, module 11 of the Big Data and Hadoop Developer course. So, in this lesson, we'll be having a look at the HBase architecture. So, before we proceed with the lesson, let's have a quick recap of the previous lesson. So, in the previous lesson, we learned the major differences between HBase and RDBMS, and then HBase and HDFS. So in this lesson, let's have a look at the logical and physical architecture of HBase, see how HBase stores the data in real time. So HBase has three major components called the client, HBase master, or it is called HMaster, and region servers. Region servers are software processes, they are also called daemons, and they get activated to store and retrieve data in HBase. In production environments, each region server is deployed in a data node. When we start using HBase, we'll create a table and then start reading and writing data. There comes a time when the table size will go really big and beyond a configurable limit. At this point, HBase will automatically split the table and distribute it to another region servers. This process is called auto-sharding. By auto-sharding, HBase automatically scales as our data grows. This is a big advantage over many other databases where you need to manually scale the system over a single server. In HBase, as long as you have another spare server that is configured, the scaling is automatic. Now, as more region servers get created, the table containing the data also gets split. So now a table is split and exists across a number of region servers. The part of a table on a region server is called a region. So as tables are split, the splits become regions. Each region server manages a configurable number of regions, say 1000 regions. The HMaster is there to assign regions, create and delete tables, monitor the region servers, and handle the metadata of the table. The HMaster is also responsible for managing region server failovers. The Zookeeper is a coordination and synchronization framework which maintains the server state in HBase cluster. Zookeeper is a distributed cluster of servers to provide this service. Generally, HBase clusters are huge and coordinating the operation of the master, region server, and client can be a daunting task. It's like a zoo out there, and Zookeeper is there to manage this and allow real-time coordination between all the different components in HBase. In a physical deployment, HBase is composed of three types of servers in a master-slave type architecture. The region servers handle data for reads and writes. When accessing the data, clients communicate with region servers directly. The HMaster handles region assignments and operations such as create and delete tables, and while Zookeeper, which is part of HDFS, maintains a live cluster state. The Hadoop data node stores the data that the region servers manages. All HBase data is stored in HDFS files. Region servers are co-located with the local when it is written, but if and when a region is moved, the data is not local until compaction. The name node maintains metadata information for all physical data blocks that comprise the files. Well, let me quickly recap what I have said a short while ago. Region servers are just software processes that get activated to store and retrieve data in the HBase. In production, each region server is deployed in a data node. When you start using HBase, we create a table and start reading and writing the data. And as the table size grows further, this table will be split and it will be assigned to one more region servers. So this process is called automatic sharding. As more region servers get created, the table containing the data also gets split. So now a table is split and exists across a number of region servers. The part of a table on a region server is called a region. So as the tables are split, the splits become region. Each region server can manage a number of regions. So if you look at the picture, you will understand this concept. The HBase tables are divided horizontally by something called row key range into regions. A region contains all rows in the table between the region's start key and end key. Regions are assigned to the nodes in the cluster or region servers, and these serve data for reads and writes. Region server can serve about 1000 regions stored in this. Now if you look at the picture, you can clearly understand the concept. So in the picture you have actually two separate region servers, and you can see the row key starting and your row key ending. That means the first region server is storing is responsible for managing 2 regions, and the second one is also responsible for managing 2 regions. You can also see the client, Zookeeper, and HBase active master in the picture. So here you can see a better look at the entire architecture of HBase. Essentially, your data, which is in the form of regions, is stored on region servers, and region servers are stored in the form of blocks across data nodes. So it is pure HDFS data in that sense. Zookeeper is the coordination service which acts between the HMaster and region servers to manage the cluster. Every data node interacts with HMaster through Zookeeper. That is, Zookeeper becomes the intermediary service provider between HMaster and the region servers. Now let me restate this. HBase uses Zookeeper as a distributed coordination service to maintain server states in the cluster. Zookeeper maintains which servers are alive and available and provides server failure notification. Now a little bit more on Zookeeper. As in HBase, Zookeeper clusters run on commodity servers. Each server runs a single Zookeeper service, and one Zookeeper service is nominated as the leader, and the rest of the Zookeeper servers are followers. A Zookeeper cluster is governed by the principle of consensus, or the principle of the majority wins. So if you need a minimum of 3 Zookeeper servers to achieve the majority vote, 5 is a practical number of Zookeeper nodes that we keep in a production deployment. As a rule of thumb, to calculate the number of Zookeeper servers, use the formula 2 times number of failures expected in the cluster plus 1. That means if we expect 3 failures in a cluster, then the number of Zookeeper servers needed are 3 into 2 plus 1, that is equal to 7. So to summarize, Zookeeper is your coordination service that we use in the HBase cluster. Each region server creates an ephemeral node. The HMaster monitors these ephemeral nodes to discover available region servers, and it also monitors these nodes for server failures. HMaster compete with each other to create an ephemeral node. Zookeeper determines the first HMaster that succeeded in creating a corresponding ephemeral node and uses it to make sure that only one master is active. The active HMaster sends heartbeats to Zookeeper, and the inactive HMaster listens for notifications of the active HMaster failure. If a region server or the active HMaster fails to send a heartbeat, the session is immediately expired and the corresponding ephemeral node is deleted. Listeners for updates will be notified of the deleted nodes. The active HMaster listens for region servers and will recover region servers on failure. The inactive HMaster listens for active HMaster failure, and if an active HMaster fails, the inactive HMaster becomes active. So to wrap up, in this particular lesson, we have learned about the HBase logical and physical architecture, and we learned in depth as to how these different components such as clients, master, region servers, and Zookeeper work together to serve as a real-time NoSQL database. That's all for this lesson.